right, our last section, ladies and gentlemen, is quadratic inequalities, section 3.6. So to graph a quadratic inequality in two variables, follow these steps. Number one, graph the parabola with the equation y equals ax squared plus bx plus c. Make the parabola dashed for less than or greater than. Make it solid for less than or equal to or greater than or equal to. Number two, test a point inside the parabola, put an X there. That's my suggestion. It makes it easier to kind of see where the point is. And number three, if the point makes the inequality true, shade that region. If it's a false statement, shade the other region. So our first example is graph y is greater than negative x squared minus 2x plus 15. So again, step one, it says to graph y equals negative x squared minus 2x plus 15. Okay, and now from that, again, since it's in standard form, let's just go ahead and use our axis as symmetry. If you recall from the last chapter, was x is equal to negative b over 2a. And in this case, our b is negative 2, our a is negative 1. So we're going to have negative 2 over 2 times negative 1. And if you work that out, 2 times negative 2 divided by negative 2 is 1, and we have another negative. So our answer for our axis of symmetry will be negative 1. So again, I'll warn you, look at the scale there. This one here is going by 2s. So we're going to go and make our axis of symmetry here at x is equal to negative 1. Okay, remember to get our y value, because we need our y value for our vertex, we're going to take f of negative 1, which tells us wherever we see x, we're going to replace it with negative 1. And if you work that out, ladies and gentlemen, you'll see that you'll get a positive 16. There, I accidentally wrote it there. That should be 15 there. All right. And then so that tells us that our vertex is going to be at negative 1 and 16. So our vertex is going to be here. And now remember, our x-intercept, when it's in standard form, is going to be that one right there. So we know at 0, it's going to be at 15. So I know it's going to be here. And then by symmetry, I know I'm going to have another one here. So I know that I'm going to have a parabola that's going to go up and down. And we know that it is going to be dashed. So let's say parabola is dashed. And remember, we know it's dashed because of the greater than there. If it was equal to, it would be solid. So again, I'm going to make a graph. And it is dashed. Number 2, it tells us to test a point. And The easiest one to use is 0, 0, so use 0, 0 if you can. And I told you we're going to put an X there. So I'll make it an X right here. And we know that we can use that one. So after we do that, we're just going to plug in that X and Y. So our Y is 0. And now we're going to use our original equation because we have to see if the inequality is true or not. So I'm going to say 0 is equal to, is greater than negative 0 squared minus 2 times 0 plus 15. So we have, when we work this out, we say that 0 is greater than 15. So is that a true statement or is that a false statement? We know that is false. All right, so if it's false, that means we're going to shade on the other side. So we're going to shade outside the problem. And in this one here, why don't I go back to blue? And you're just going to give me, say, something like this. I guess it'll be interesting to see what it looks like when you do it on the big ideas online. All right, so that was example 1. Now example 3, I'm skipping a word problem here. So we're going to follow the same steps for a system of inequalities. So on a system of inequalities, we're going to graph y is greater than x squared minus 4, and then y is less than or equal to negative x squared plus 3x plus 4. So step 1, we're going to look at both of them. So I'm going to kind of do each one by itself. So y is equal to x squared minus 4, and we're going to again set that equal to 0. So this part right here is going away. All right, so now remember, that's the difference of two squares. If you don't remember, we're going to be doing that next chapter. So we can write that as x plus 2, x minus 2 equals 0. So by the 0 product property, we know that x is going to equal negative 2, or x is going to equal positive 2. So on that one there, we can graph one here, we can put one here, and on here our vertex is again, and this one here is going to be 0 and negative 4. Again, we look here, it's just greater than, so we know we're going to do a dashed. So if I do that dashed, it's at 0 and negative 4. And we know that it is going to be dashed, so it is going like this. And again, we're going to test 0, 0. So when we plug that in, we're going to have 0 is greater than 0 squared minus 4. So is 0 greater than negative 4? You're going to tell me yes. So we're going to shade inside, and don't forget, I told you to put an X there. I'm using a purple one here. You'll kind of see why I want that. So now I'm going to shade inside. So when I shade inside, since I have two of them, I kind of like to cross-hatch it here. So I'm going to go like this. All right. So the second one, and why don't I make the second one be red? So on that one there, we're going to solve for y is equal to negative x squared plus 3x plus 4. And again, remember we're setting that equal to 0, so I can get rid of that. Okay. So now on this one, I'm going to change it up here a little bit for you. So I'm going to say I'm going to factor out a negative. So I'm doing it a little different than I did on the first one. I'm trying to show you more than one way, right? So remember, if I factor out a negative, that'll give me x squared. That means I'm going to have a negative 3x. I'm going to have a negative 4 equals 0. Okay. And again, so why did I do that? Because now I have a coefficient of 1. It's positive there. So I can do x and x. And again, this one here is negative. So that means automatically one's positive and one's negative. You just have to figure out where do I put what are factors of 4 that when I multiply them give me 4, and when I add them give me negative 3. And you would tell me that's negative 4, and you would tell me that would be plus 1. All right. So by the zero product property, again, we can say that x is equal to negative 1 or x is equal to 4. So I'm going to do those two there. So x is equal to negative 1. It's going to be here. And x is equal to 4. That one's going to be there. Remember, now since I use the x-intercepts, I can say that the axis of symmetry is going to be the average, so negative 1 plus 4 divided by 2, or 1.5. And when I take f of 1.5, I will get 6.25. All right, so that's saying we're 6.25. So let's see, our axis of symmetry for that one would be 1.5. So that would be right here. And then we're going to be at 6.25. So our vertex is going to be there. And I'm going to make a solid line this time, because if you look there, it's less than or equal to. So I'm going to make a solid one here. Remember, these don't have to be perfect, ladies and gentlemen, at least when you're drawing it freehand. Again, I can test 0, 0, because it is inside there. So if I test 0, 0 there, so let me tell you, we made it solid. And when we test 0, 0, okay, we'll get that 0 is less than or equal to 4. All right, I just plugged in that up here again. I plugged in 0 and 0. All right, and is 0 less than or equal to 4? You would tell me yes. So I'm going to do the same thing here. I'm going to cross-hatch it here. And I think once you do this on the online version, it's going to make it a different color. It'll probably make it purple. If you're doing this by yourself, the last thing we'd do would be 3, identify the I like to call it doubly. So the double shaded region. Which, again, I'm going to make it purple here, and this time I'm just going to now notice it's all this where I had the blue crosshatch and the red crosshatch. So it's all of this area here. And what we would find out is if we chose any point in there, it would make both of those equations true. Okay? So that's using the doubly shaded. And then finally, the last thing we're going to talk about today is a quadratic inequality in one variable. So remember, on this one here, we had y and we had x. So it had two variables. But they're saying if we have one that's in one variable, we can write it as, and again, instead of writing it down 4 times, I just went ahead and said you could write it as ax squared plus bx plus c. Our 4 choices are less than 0, greater than 0, less than or equal to 0, or greater than or equal to 0. And again, you can solve these by using algebraic methods or graphs. So I'm going to show you how to do it algebraically. And it's kind of basically the same kind of thing when you do a graph, except you'd actually kind of see a parabola. So example 4, solve x squared plus 4x minus 32 is greater than 0 algebraically. So first, you're going to set it equal to 0 and solve. So we're going to have x squared plus 4x minus 32 is equal to 0. All right. So when we do that, again, I have an x there. So when I have an x there, it's kind of easy to do. So I'm going to put x times x. The last term is negative, so you know automatically one is positive and one is negative. And what are factors of 32? That when I multiply them, give me negative 32, yet when I add them, give me a positive 4. So you would tell me it's plus 8 minus 4. So by the, by the zero product property, we know that x is equal to negative 8, or x is equal to positive 4. All right. So now we are going to plot those on a number line. So on the number line, we are going to take our negative 8, and we're going to take our 4. So I'm going to put one here, and I'm going to put one here. All right. Now, I said, all right, are they going to be opened or closed circles? I've left them open, but we could close them if I need to, right? But what would tell us we would close them is if I had this being greater than or equal to. Since it is just greater than, that would tell me that both of them have to stay open. So our answer here is open. Okay. So now these critical x values partition the number line into 3 intervals. So you should be able to see that, because if I drew a line through here, a line through this one here, we do have 3 intervals. There's 1, there's 2, there's 3. So they're saying on these ones here, test an x in each interval to see if it satisfies the inequality. So you're going to choose a number in each one of them. Okay. So I'm going to test x is equal to 0, because that one's always an easy one. And then I'm going to test, well, since I have it here, I'm going to do 6, and I'm going to do negative 10. I could have had more numbers on there too, But again, I would probably still do the ones closest to it. Remember, I cannot do -8 or 4 because those are where my intervals are broken up. Okay, so I'm going to do x is equal to -10. I'm going to do x is equal to 0. And then I'm going to do x is equal to 6. So if I do x is equal to 0, -10, let's do the hard one first. So I'm going to plug it into my equation up here. So I'm going to do -10 squared, okay, plus 4 times -10 minus 32. And again, we're wondering, is that greater than 0? All right. So if I simplify this, I'll get 100 minus 40 minus 32. So if I add all of those, again, we're asking, is that greater than 0? We'll have 28 is greater than 0. And you're going to tell me yes. If x is equal to 0, I'm going to do the same thing. 0 squared plus 4 times 0 minus 32. Is that greater than 0? Let's say -32 is greater than 0. Again, that's my question. And that one's a big no. And finally, the last one, I'm going to say 6 squared plus 4 times 6 minus 32. Is that greater than 0? I'll have 36 plus 24 minus 32. Is that greater than 0? If I work that out again, I'll get 28. Is that greater than 0? You're going to tell me yes. Okay. So if I was to graph this on the line here, okay, I'm going to say that everything over here is true. So I'm again graphing whatever's true. Over on this side, if it's true, I'm going to graph it. Okay? So if we look at it, the solution is, well, if I look here, all of this right here is less than -8. So x is less than -8. Or if we look at this one here, we'll get x is greater than 4. Okay? Now, I'm just going to tell you on this one here, if it was true in here, you would have told me that x is between. So here, I'll go ahead and write this down just so you can see it. If the middle portion was true, which again, I know it's not, but if it was, you would have told me that x is between 4 and -8. I'm just telling you right now because you'll probably have one like that on your homework. Okay? And remember, if those were filled in circles, it would have been equal to. All right? So again, this part is not part of it right now, but I just let you know that. So go ahead and do your homework, and we'll be doing our practice test tomorrow.